So as we work with quadratic formula,
You've actually been doing this in math for several years. We work with the quadratic formula, and it is going to be negative b plus or minus negative b plus or minus negative b plus or minus the square root of b squared minus 4ac all over 2a. That's actually x equals. So that comes from your standard formula of a quadratic equation, which is ax squared plus bx plus c equals 0. And the a, b's, and c's are coming from the coefficients and the constants of the quadratic formula. So here in that first example, in order to get into standard formula where we have equal to 0, we would have to add 4 to both sides. So we now have, looking at that example, we're going to have x squared plus 4x plus 4 equals 0. Now then we can look at, okay, what is the value of a, b, and c? And then we know that x is going to be 1, or a is 1, b is 4, and c is 4. So now all we have to do is turn around and populate the quadratic formula. So we replace the a, b, and c, so we end up with negative 4 plus or minus the square root of 4 squared minus 4a times 1 times 4 all over 2 times 1. And we do some order of operations and simplify that. And we have negative 4 plus or minus, then the stuff on the inside. We have 16 minus 4 times 1 times 4 is going to be 16, all of that over 2. And then we end up getting negative 4 plus or minus 0 over 2. And we know that x is going to be equal to simply negative 4 over 2 or negative 2. And that is simplifying using the quadratic formula. If we look at this next example, we are looking at x squared plus 4x minus 3 equals 0. And I'm already in standard form, so I can take and find a is equal to 1, b is equal to 4, and c is equal to negative 3. Using the quadratic formula, I have negative 4 plus or minus the square root of, let's see here, 4 squared minus 4 times 1 times negative 3. So again, populating those values into my quadratic formula. All of that is going to be over 2 times 1. And as I go through and I begin to simplify, I have negative 4 plus or minus the square root of 16 plus 12. Negative 4 times a negative 3 is going to give me a positive 12. All of that over 2. Continuing to simplify, I have negative 4 plus or minus the square root of 28 over 2. Again, simplifying that radical. And I have negative 4 plus or minus, should be 2 square root of 7 over 2. And now I'm going to use that common denominator when I split it up here in a second. And so I can simplify my expression to the most, the simplest form using some of those math skills. And I'm doing every step out here for you so you know what I'm doing. But that 2 is a common denominator, and then I have negative 4 over 2 is negative 2, and then plus or minus. My 2's cancel out to 1, and I have negative 2 plus or minus the square root of 7. Or negative 2 plus the square root of 7, or negative 2 minus the square root of 7. And applying the quadratic formula, I mean, look at this. Your school's jazz band is selling CDs. The total profit is P. The amount your band charges depends on the amount your band charges, X. So they've given me this quadratic equation. They want me to find the profit. So what is the least amount in dollars that you can charge for a CD to make $100 profit? Well, P is 100. So what I want to do is I want to turn around and do some substitution for P by putting in 100. But thinking about what a quadratic, we have negative x squared, what a quadratic equation or function looks like, well, it's going to be a upside down parabola, and the x-intercepts or our roots are what we're looking for, and we're looking for the one that gives us the least value. least cost in dollars. So as I go ahead and do some simple math to get this, into my standard form, I know that P is profit, and they want me to make a profit of $100. Well, I've gone ahead and I substituted in for P, $100. I do my inverse operations to get it into standard form, and I have negative x squared plus 48x minus 400 equals 0, identifying my A, B, and C values, and then using those to populate my equation. So I have negative 48 plus or minus the square root of 48 squared minus 4 times negative 1 times negative 400. All of that is going to be over 2 times negative 1. And we've done some simplifying here. In just a second, we're going to figure out what my two values are. So there you go. We've done the simplifying, and you may need to stop it here, but two values came out. One allowed me to charge the least amount, which was $10.73, and so far so good. Very simple quadratic equation. All right, so as we continue into the quadratic formula, and we're going to talk about the value of the discriminant, and the discriminant is that part that was inside the square root. And we know that there's some properties in our square root that are going to identify the value of the discriminant or the number of solutions. So when the discriminant is b squared minus 4ac, when that is greater than 0, we're going to have two solutions because we can find two roots. When it is less than 0, we're going to have 0 real solutions because we can't find the square root of a negative number yet. And then when it is equal to 0, we are going to have one real solution, and this is what those look like. And there, with two real solutions, we're going to cross over the x-axis twice. With no solutions, no real solutions, we're not going to cross over the x-axis. And then for one solution, since x equals 0, or the discriminant equals 0, we will touch the x-axis at one location for that one real root. So if we go here and we look at some of our examples, and let's see, what is the number of real solutions in A there? I have 2x squared minus 3x plus 7. A is 2, B is negative 3, C is 7. So I populate my discriminant, and it turns out that I have negative 47, which is below 0, less than 0, so we have no real solutions. There you go, no real solutions. On this next example, we're going to start off with doing our inverse operations and get it to x squared minus 6x minus 5, and then my A is going to be equal to, we're going to get there in a second, but A is equal to 1, B is equal to negative 6, and C is equal to negative 5. Go ahead and substitute those values into your discriminant, and I'm going to have negative 6 squared minus 4 times 1 times negative 5, and then that gives me 36 plus 20, or a positive number, and a positive number is greater than 0, and that's going to give me then two real solutions, or two x-intercepts, also known as solutions, roots, x-intercepts. And then looking at this word problem, again, they've given me a quadratic equation, the trajectory of a golf ball, which is going to be a downward opening parabola. They want me to figure out when the height of the football, or the height of the ball in seconds. When will the height be 110? When will the height be 115? Well, I start off here, well, the height is equal to h, so I would substitute in the value of h, so I take my quadratic equation and make it equal to h, or the height, which is 110. And then, guess what? Let's just move on to the next example, and we'll come back to that. So I make it equal to 115, do my inverse operations to get it into standard form. And there you go. I've got it into standard form, A, B, C. I'm using this to figure out what my discriminant is going to be. So I've gone and I plugged this information in, and I have 85 squared minus 4 times negative 16 times 114 and 11/12, which is going to be equal to, well, some big numbers here. 7,225 minus 7,354 and 2/3. We know it's going to be a negative number. The negative number is larger than the positive number, so we're looking at negative 129 and 2/3. So if the discriminant is negative, we can't find a square root of that, so there's going to be no real solutions. And of course, if you were to go back and do the previous example of 110, doing the same substitution, you would find out that we have a solution at 190 and 1/3.